Now I am going to explain the concept of circular motion. We can take it as two parts, uniform circular motion and non-uniform circular motion. Okay, what is uniform circular motion? Now you consider a stone tied to a string and rotated like this in a horizontal circle, right? If it is rotated at uniform speed, then we call it as uniform circular motion. What is speed? Speed is magnitude of velocity. Okay, now take this. Center of the circle is O. The length of the string is forming the radius R. Consider the velocity at the 2 points A and B. The magnitude is same at A as well as B. But note the direction change. So, if a body describes a circle with uniform speed, then it is undergoing uniform circular motion. That means it will have only a radial acceleration pointing towards the center at every point AR, and tangential acceleration, that is along the tangent, there is no acceleration for this part. We can split the acceleration as radial acceleration and tangential acceleration, but tangential acceleration is 0 because it maintaining uniform speed. Okay. Now let us define certain terms. The angle AOB, AO is known as radius vector. The angle swept by the radius vector is the angular displacement. Okay. What is angular velocity? Angular velocity is represented by omega, which is equal to d theta by dt. Linear velocity is dx by dt, angular velocity d theta by dt. Right. What is angular acceleration? Angular acceleration represented by alpha is d omega by dt. So what is uniform circular motion? Uniform circular motion, a body describes a circle with uniform speed. There is no tangential acceleration, there is only a radial acceleration. What is this radial acceleration? The radial acceleration, otherwise called as centripetal acceleration, it is given by v square by r, where v is the speed and r is the radius of the circle. Because there is a centripetal acceleration, there will be a centripetal force for the particle, otherwise it cannot describe the Fr, which is equal to mv squared by r. So centripetal acceleration and centripetal force. The relation between the linear speed or linear velocity and angular velocity is v equal to r omega. Therefore, we can write the centripetal acceleration as r omega square and the centripetal force as mr omega square, where omega is the angular velocity. Suppose the particle performs n revolution per time, per unit time, then how will you write omega? Omega can be written in terms of the time period as well as the frequency of revolution as omega equal to 2 pi by t. What is t? T is the time period of revolution, that is time taken to complete one circle, one revolution. N is the number of revolution per second or frequency, then n equal to 1 by t, therefore omega becomes 2 pi n. This formula will be using in the problem. So if a body performs circular motion with uniform speed, maintains a speed constant at every point, it is undergoing uniform circular motion. Suppose the speed changes, dv by dt is not equal to 0, then it is performing non-uniform circular motion. It will have a tangential acceleration as well as a radial acceleration. Therefore, total acceleration is given as root of ar square plus at square. So this is the concept of circular motion, uniform and non-uniform. A wheel is subjected to uniform angular acceleration about its axis. Initially, its angular velocity is 0. In first 2 seconds, it rotates through an angle theta 1, and next 2 seconds, it rotates through an additional angle theta 2. Calculate the ratio theta 2 by theta 1. So this problem is based on circular motion. We have been given the initial angular velocity as 0. Okay, so omega 0, initial angular velocity is 0, and it is having a uniform angular acceleration alpha, and the time interval t1 equal to 2 seconds initially, then further 2 seconds. So t2 equal to 2 plus 2, 4 seconds. Okay, right. Now, how to solve this problem? We have to use the equation of motion. What is for linear motion? Ut plus half at square. Now this is angular displacement. This is initial angular velocity. So omega 0 t. This is angular acceleration. So this is the equation to be used for circular motion or rotation, right? So angular displacement becomes angular displacement, linear velocity becomes angular velocity, linear acceleration becomes angular acceleration. Okay. Now let us take for the first interval t1 the angle described as theta 1. This is 0, so half alpha t1 square. Next we will take theta 2 as the angle described in the next 2 seconds. In next 2 seconds. So what is the total displacement? It is theta 1, already it has described theta 1, next 2 seconds theta 2. Now the time interval is 2 plus 2, 4. So alpha t2 square. Dividing 3 by 2, theta 1 plus theta 2 divided by theta 1 gives us t2 square by t1 square, 4 square by 2 square, 16 by 4 equal to 4. Okay. So cross multiplying, we get theta 1 plus theta 2 equal to 4 theta 1, or theta 2 by theta 1 equal to 3. So the ratio of the angle described in 2 successive intervals becomes 3, theta 2 by theta 1.